apologies for being a bit late, but I missed a connection at the bus station. And as Shika says, I'm coordinating an EU project, which is what I was doing until 10:30 this morning, busy contacting partners, preparing for a big meeting next week. So I apologize for that. So I'll tell you something about EUMINA Fab. The thing is, we've been now running 4 years, and so we've gathered some experience. We had a very strong learning curve at the beginning, and I'd like to share that and where we are now after these 4 years. Okay. This is an overview of the presentation, so a bit about the project, where we started, how we work together with the users, how our technologies are key technologies, a summary of our achievements, and the way ahead as we see it at the moment. We're now at the moment 12 partners. Initially we were 10. One had to leave because of involvement with a very good industry project. We then, because of recalculating access budget, unit costs and all that, found a certain amount of free money within the consortium, so we could take in 3 extra partners, which really helped us in many ways. So these extra partners here were CRAN, the Free University in Brussels, and the University of Birmingham. We have, following from the last talk on metrology, we have a partner, MPL, probably you know, Richard Leach, and they're doing some standardization studies with us on the metrology side. So, the partners like Nano can each offer up to 20% of their user time within EUMINA Fab. This access is free of cost for public research. Here is a little star by the end date of February 2013, in that we just have an extension till the end of August this year. The reason for this extension is that actually our user projects are much more complicated than we originally expected, and our final call, we actually brought forward the date of the final call a month, and we brought forward the closure date in comparison with the description of work, but because we need so much external participation in the user projects, it's not possible to get that finished by the end of February. And so we've been kindly granted this extension till the end of August. So far, adding up our access, we've allocated 6,500 units of access. These units may be days or hours. We have a value of over 2.2 million euros in the access that we've allocated. That, I stress, isn't quite used yet because the users have to come and complete the project before this access is actually used. This is more than it's about 600,000 euros more than the access budget of our description of work. That's because we got so many really good proposals that our partners are prepared to do the projects anyway. That's sort of success story there. We also need to be a bit like Ryanair and do a certain amount of overbooking, because if this is only allocated funds, it's not used access budget, which means that if for any reason a user project cannot run, then that allocated budget falls away, and so our access in the end in the project won't be quite so great as it looks here. So we're calculating that in and taking the risk, and we know that we're not going to get all the access money back that we have earned in a way, but we've got a lot of great user projects. Our final call closed, and as I say, access is oversubscribed. This is the technology just as a list. If you look on the web page, these are the names of the installations that we have. We divided them into 4 categories: micro-nano structuring, thin film deposition, replication, characterization. The thin film deposition has been a bit underrepresented in the user projects. For the most part, we're in the micro-nano structuring and the replication and quite a lot of characterization. The TEM is very subscribed. the metrology tends to run in association with another project as an extra service. Yeah, so, but that was the beginning. We set off with a technology toolbox. We said we've got some great technologies. They're quite expensive, quite a lot of them, and not everyone in Europe has them, so please come and use our technologies. But shortly we'll tell you that things didn't work out that way. There's some examples of what you can do with micro-nano patterning. There's reactive ion etching, these very high aspect ratio structures with a lithography suitable for gratings, for example, in X-ray diagnostics, to reduce the dosage necessary. We have in the replication, it's mainly based on either injection molding or nano imprinting or hot embossing. Philips had their E-beam and the STIL to make nano stamps that work on this curved surface. So we go from a range of structures in micrometer size structures and down to nanoscale. The thin film deposition, I say, is a bit less represented in the projects. To deposition of single structures, arrays of nanoparticles on arrays. We can also previously structure the template to be able to make a targeted deposition. OLED display is a speciality of CRF Philips, Fiat, sorry. And in characterization, this is the metrology at NPL. And nanomaterials characterization in Grenoble and some TM images from KIT. So we have quite a broad portfolio of technologies. Who were our users? I did a kind of analysis of who the users actually were. The Commission, of course, likes us to improve our number of industry users. We have at the moment 19% industry users. And here's a list of some of them. We have the Trinian Envy made a biosensor. There's a startup which is just starting up at TCD. They use the host partner at Philips. There's other users are from industry here. We offer course experience for young researchers. These are all PhD students who've had the opportunity to travel and run their samples at the partner sites. We also find that we're a sort of support platform for other EU projects and other national infrastructures. For example, the Soleil in France. And there's a couple of other projects, one called Polaric and one called the Morgan Project, where they found that they needed some part structuring and couldn't get it done elsewhere, so they came to us. And of course, we mustn't forget the mature researchers, and we have some professors also that come to visit from Bulgaria and Portugal, Romania. So we serve everybody, right? As I said, we didn't just come. We found out that this technology toolbox idea was a great starting point. And what happened was, we noticed at the beginning, in our description of work, we reckoned that a user project would take 2 or 3 days on an installation with maybe a maximum of 5 days. But we found that in practice, the user projects were taking more like 7, 10, 12 days. And we thought, what's going on here? We can't serve as many users because we're serving the ones we have for longer. And so I got on the phone and spoke to our technology experts, and they said, okay, so why are you taking 3 times as long to do your job as you said you would? And it came about, and we made this graph from it, is that it's a kind of iterative procedure. It would be quite common, a technology expert would say, but we've never worked with this material before. It's really tricky to structure. We have never done this sort of parameters before. We've never made this size or this shape or with this indentation. And everything was, well, it's a first, and we need to discuss, with the user what they actually want to use this for in the end, so we can give them what they're really looking for. So that's why everything took 3 times longer on average than originally imagined. Our reviewers at the review meeting really liked it, said it's a mini collaborative project, and so that's here where we have this sort of iteration that things take longer. In terms of the unit cost, because you're familiar with all that, we have here the intake process, we have an evaluation where you're not meant to do any instrumentation work except, well, we do because you have to, and then we actually do the job and make a report afterwards. So when we're looking at what these projects are actually related to, are there going to be any use? What's the impact of EUMINA Fab going to be? Are we wasting our time, or wasting your money, or is something good coming out of it? So we looked at what sorts of application areas were relevant. What did the proposal say? Where are the application areas that are relevant to us? And this is a sort of brief summary overview. There's nanoscience and nanotechnologies here. And as you see, they're mainly in this area. The materials is a bit out on its own. Okay, it's clearly the largest category. These are mainly the characterization technologies. When you take a further analysis of what the materials projects are, it's mainly the materials characterization. So we have life sciences, then our major category, and that's doing different structures for bioimplants, drug delivery devices, bioarrays, biofunctionalization of surfaces, and so on. Engineering technology is a bit generic. You can't yet say where the work's going, but they're just trying to make new structures and devices. The physics was quite interesting because these are specific applications for specific high-end projects. Nanoscience and nanotechnologies are new ways of trying out mainly for structuring surfaces and functionalizing surfaces. So here's a summary of some types of users, things that users can do or are doing. So there's the lenses, there's gratings, a micro-optical bench, there's noble metals once more, a waveguide, and this electrophoresis chip. And so it is relevant for different areas. We also looked at how mature these technologies people are doing. Are they ready for application? Is it going to be a new product tomorrow or in 10 years? And what's going on there? So, so we took a look at this as to what the users wanted to do. And we categorized it in 4 categories. So characterization, as I say, is mainly a thing for the materials projects. Certain number of projects were testing the feasibility. So they wanted to see, would this work? Is this possible? So they're testing feasibility things for new production processes, engineering technology, and some life science. They're also, in some cases, making prototypes. They're like prototype devices, LED devices, biosensors, and so on. And we see the biggest selection of prototypes here in the life science area, and a certain amount in this engineering technology. A lot of it is molds for injection molding, stamps, and so on. And then a few projects make objects. These are the one-off high-end applications, or a particular device. Someone wants some cantilevers made so that he can do some different studies. The cantilevers are not prototypes because they're actually an object himself for that the user needed to be able to carry out his further experiments. So we think this gives an indication of, we've also done more details I haven't show here, of which technologies are more used for this feasibility type work and which are more nearer the application and making the prototypes. So we like to see our technologies as key technologies. We have this micro-nano key technologies. For example, if you take a variety of materials like polymer or DNA, ceramic, you have them relevant for application areas, and here I chose out the health area to make it more relevant for you. And here's some ideas of what we can do. We can, with polymer, we can use the deleaguer to make some gratings for use in diagnostics in the health area. We can use dip pen nanolithography to deposit molecular layers for making biosensors, make dispensing units for drug development studies using injection molding, and nano imprint lithography, which makes nanomicrostructures to make a replication stamp, and micromilling to make molds for microfluidics in drug delivery devices. So here we like to see, here is you've got your material, you've got your structures you want and the application that you're aiming for, and these are the technologies that transform the material into something useful. So what have we done? This is a summary of our achievements. We tried our very best to create a one-for-all and all-for-one approach among the partners. So the partner here is the user who says, hey, our Spanish partners are great at this. They're forever talking to people they know and sending them and saying, you should go to Philips, you should go to Karlsruhe, you should go to Dublin. It's a really super way they go about this. We enable a real-world testbed for emerging technologies. A lot of these are new instrumentation. There's only a few items of it at a time, so so they're getting tested in a real world where users want to use it, not just a little ivory tower where a researcher spends his 24 hours a day doing his own thing. So it's tested in the real world. And we've got this niche of functional solution provider, like I showed on the graph with the iterative picture. And this enables a cross-fertilization of ideas, and it makes sure that one technology in one country, if we do have parallel technologies, that they don't have a sort of divergent evolution, but that this cross-fertilization means that they both grow in different countries at a similar rate. And we have this common platform for marketing, exchange of knowledge. We can build new roads into other user communities that we wouldn't be able to reach on our own. And this increased mobility of users. We have 139 users, I think, at the moment, and they're all transnational access. Like you have, they're coming from one country to another, so it contributes quite a lot to mobility. And this is our main thing. We've developed this application approach for functional solutions, and this is actually further than the technology toolbox, which was originally planned in our grant agreement. So that is a really major achievement. Just to come up to closing now, we do have some challenges ahead. The end of the project is in 6 months now, but we really want to sustain this advance that we've made over the last 4 years towards this European infrastructure. And this is what we are: multi-material, micro, nano fabrication and characterization. Fabrication doesn't include particle fabrication, which is a bit more your thing. And the characterization is usually associated with the fabrication side. So we want to consolidate this progress. We want to integrate with other MNT providers in the same area. We want to be energetically open to new users and avoid the risk of returning to isolated technologies. Okay. And so we want to, this is the common identity and a joint marketing platform. And it's something that we can do together, reduce the marketing cost of partners. But also we want to increase the synergies with relevant platforms clusters and encourage uptake of these technologies among a broader community. But for that we need some extra funding. And we also would like to develop on this application idea and form some application hubs. Energy, health, ICT, optics, photonics, metrology and characterization. And perhaps we can discuss, Kai, with where possible cooperation might be here. And So to link this value chain then from technology to market, and of course in doing so also to improve the outreach to SMEs, because that is actually pretty poor with us. We want to go beyond the SMEs we know to others, and in order to speed the uptake of these technologies and bring in new ideas, but this actually requires quite significant extra funding to get this coordinated and on the move. So that's where we are, application hubs, the types of users, and our aim is to be a hub for knowledge-based micro and nano technology functional solution provisions and provide these essential links in the value chain. So I thank you very much for your attention and the invitation and being a part of this event. Okay.
Okay. Time is proceeding, but I think a quick question would be possible. Are there urgent questions from the audience?
Hi. Next week in Brussels, the Nano Futures discussion is in the high-level planning group Nano. Do you know if any prolonging, because I haven't seen this initiative in the planning for the next years, well, especially your outreach for the SMEs, I think would be very interesting as an aspect of the new policy. So
yeah,
why isn't it in?
Why isn't it in where?
In Nano Futures discussion with regard to the programming of the allocation of the budgets for the next FP8.
Yeah, why isn't it? It runs under infrastructures, which is it's been capacity. So there's like different world, and we are involved with Nano Futures, are kind of involved in a kind of fringe way with Nano Futures, like I registered. And they're very interested in infrastructures, but the actual promotion of the infrastructures runs under capacities, and I think there's some sort of reorganization. I know there's a recognition that infrastructures are important, but I'm not sure where the funding goes. But I'm happy to be connected and discuss. Okay.
Okay. Due to the time, I would proceed with the next talk. It's Michael Hagelstein, and he will tell us something about